Okay, here's our first solution where we're expanding x plus 5 to the power of 18 and trying to determine the coefficient of a specific term, x to the power of 15. So since we know our power on this binomial, this is an easier type of question. We are going to have to choose something from 18 so that we get x to the power of 15. And since that's just plain old x, it's pretty obvious that we need to have 15 there as our exponent, and the remaining, I guess, leftover exponent has to be 3, because 15 and 3 will add to 18. So you can go 18 choose 15 or 18 choose 3. And of course, the part that's going to be your coefficient is going to be 18 choose 3 multiplied by 5 cubed. Okay, in our next problem, we're looking for the constant term. So of course, that's also the term in x to the power of 0, if you want to think of it that way. Again, we know our n value on our binomial here, the power that our entire binomial is raised. So that's going to be 10. And we know we have to deal with a combination that's 10 choose something. And before we figure out what that something is, we have to tinker with our two terms here and decide what the two powers are going to be so that we get no x's left over and they all cancel out, which essentially means, of course, we need the same number of x's in the numerator here as we have in the denominator. So a little trial and error, splitting it in half, it being your power, is a good place to start and multiply. We get 15 on the top, 10 on the bottom, close but not close enough. And then maybe tone this first one down a little bit because we had too many on the top, right? So 4 and 6 as our two powers gives me a dozen x's on the top and a dozen x's on the bottom. So therefore I can say my binomial coefficient here, or my combination, is 10 choose 6 or 10 choose 4. So our constant, really, which is the coefficient on the x to the power of 0 term, but of course most people would just call that the constant, is going to be 10 choose 6, x stuff is all gone, and minus 2 to the power of 6, and of course that even power is going to swallow up that negative there. So there's your constant term, 10 choose 6 multiplied by negative 2 to the power of 6. Okay, our next question is x squared plus k over x to the power of 21, and we're looking for values of k such that the x to the power of 30 term has this coefficient of around 7.7 million there. So the good news is we know our n value again, so we know we're starting off with 21 choose something. So here's where we can tinker, might be the best option, fastest option, open to you. Tinker with two powers that add together to give me 21 that reduce down to giving me an, I guess, 30 x's multiplied together in the numerator of this term. So let's see, what do we got in the second one? We got k over x. Okay, so just to show you that I'm tinkering here, so I'm trying to get 30, so of course we probably should at least start with 15 here, right? So of course if we start with 15, that doesn't make sense because right away my 30 is getting reduced down by the 6 x's in the bottom, so at least it's a good place to start. So let's just keep bumping it up. If we go 16, this has to be 5, right? So that's 32 minus 5. Tinkering is a bit weird, but eventually we'll get there. And remember, the powers have to add to 21, so as soon as we decide that 17 might be a possible option, this has to be 4, because 17 and 4 give me 21, and check it out, that works. We get 34 x's in the numerator once we multiply those powers, and only 4 x's in the denominator, which means I'll probably just say 21 choose 4 is my combination here. So that sets up this equation, which is going to be 7.7 million, we'll call that one. That exact number should produce that coefficient on the x to the 30th term. So we're going to have 21 choose 4, x stuff is all gone. Here's our k to the power of 4, right? So of course I don't need to consider the x to the power of 30 anymore, right? You can divide both sides of the equation by x to the power of 30 because it's k we're honing in on here, or simply just disregard the x term. It's the coefficient, of course, that we want to match up here with all possible values of k. So I guess on your graphing calculator or Desmos, divide both sides by that 21 choose 4, and then don't forget to take the 4th root. And if you forget the plus or minus, no worries. I think I'll just I think I'll just raise that to the power of a quarter here, which of course is a fourth root. Same thing. If you forget your plus or minus, of course it is handled for you in the answer key. So once you punch that into your calc, you'll see that the two possible k values are plus or minus 6. Okay, and the last question, and this was a tough one to say the least. Anyway, we have a binomial here. We do not know the n, which is always problematic, and we're looking for an x to the power 19 term, trying to secure a coefficient bigger than 200,000. So I guess you have several options open to you. A lot of you could have just taken your TI Inspired and try different values of n, and then try to secure this x to the 19 term, and then eventually figure out what you need for a power of n. That will all work, but I'll try to kind of take a little more rigorous approach here by setting up our term at least, right? So I don't know n, which means right now I don't really know r either. And what really makes this hard is, I'm sure you've noticed this, having those x's on the bottom as well. So it's not just a matter of making this 19, right? Because if that's 19, then of course, right, those other x squares are going to interfere with what's happening here, which makes this a challenging question. IB would be proud of me for constructing this, I think. Okay, so I guess I don't know my r, so at this point, I guess there's not much in the way of tinkering here, but I think I will call that r and make that second part of my combination r. So we got way too many unknowns, right? So that's probably a place to start. And again, if you didn't do it this way, no worries. So long as you obviously had some kind of a plan in place, choosing some n values, you know, and making sure that, you know, you have the correct power on your x. You can obviously do a little guess and check and inspection and eventually get it. So let's make sure that this is, well, I guess it's really greater than is what we're looking for. But as a starting point, we want to get as close to 200,000 as we can. So I guess I'll stick with the inequality though, just to be clear. That's 200,000. 200,000? Yeah, 200,000 x to the power of 19. So that means that I want my power to be 19. So I guess the next step in all of this, go with just black obviously, is look at the powers of x. We'll multiply these powers here, and of course that's a power of 1. And I guess we'll write it out. That's going to be x to the power of n minus r multiplied by 4 to the power of r all over x to the power of 2r, because of course we'd have to raise the x squared by that power of r and multiply those powers as well. And I'm just going to kind of quickly, I'm going to say mindlessly copy it, but not too mindless, so you put an extra 0 on there. Okay, so now what? We can subtract those x exponents now, right? Because we're dividing by some, and then maybe, just maybe, we're getting somewhere. Okay, so now it's going to be n minus r minus 2r, so that power now is going to be n minus r minus 2r multiplied by 4 to the power of r, and we got to make sure that that is all bigger than 200,000 x to the power of 19. Okay, and let's clean this up too without rewriting the whole thing. Minus r minus 2r is of course just minus 3r. And there we go. So now what do I know? Well, I guess, you know, maybe I just created a maybe slightly better form than the original problem to help you do some guessing and checking here, but let's see how much more we can hold up some rigor for. I know that that has to be 19. Right, so it's almost like my first equation here, right? I have to make sure that n minus 3r is 19, which I guess would suggest that n would have to be 19 plus 3r, or 3r plus 19. So I guess that just kind of gets rid of two moving parts in our expression, and I definitely would still be taking my TI Inspire or Desmos and tinkering with things to make sure that you're getting a power bigger than 200,000. But let's go one more step here first. So I think I'm going to opt for putting 19 plus 3r instead of n in my combination. Maybe we'll see if we can keep the color coding alive here. Now, of course, n minus 3r is equal to 19. That was more or less the connection we're making there, first piece of information. So notice the x to the 19 is kind of irrelevant. Oh, and I just noticed that should be a power of r there. That was a big mess up. Glad I caught that. So that's not multiplication, of course, that was an exponent. And where we just were, of course, this is now going to be x to the 19, so we can drop that off, right? So kind of mindlessly copying that for a few more seconds. If I make n minus r equal to 19, then both of those will be 19. So let's not worry about that. That is all gone. So a little bit of work, and I'm not sure if that was necessary or not, but at least it gives us maybe a little bit more refined expression to work with. So in terms of r. Now the only problem is with this, and I took some sympathy on some of you, the n solve never works when there's variables top and bottom here, right? So that's kind of unfortunate. So to finish this question off, you would just try some values of r, and please be aware that r, of course, could be 0, right? Could be 1, and it's going to keep going all the way until what n is, right? So of course we don't know what n is, so if I was doing this, I'd just try 0 in here, and you're going to get 19, choose 0, which is 1, 4 to the power of 0, which is 1, so that's a bad place to start. And doing that, and I will show you on your Inspire, or I guess my Inspire screen there, after picking r equals 3, you can see that that actually is a number bigger than 200,000. So that means with a little bit of tinkering here, r equals 3. So more importantly, n would have to be, maybe rewrite it, yeah, why not? N would have to be 19 plus 3r, and if I'm suggesting r is 3, meets the threshold, 19 plus 9 more, 19 plus 9, yeah, 19 plus 9 more is going to be 28. So to be super clear and a tough question to round out our solutions here, n is 28.